Welcome back. This is an Aleks study video on assigning oxidation numbers. Oxidation numbers are helpful when you're determining whether or not you've gained an electron in a chemical reaction or lost an electron in a chemical reaction. So if you have an assigned number, if you have a number that you know where you started from, and then you determine the number at the end of the reaction, you know whether you gained an electron by becoming more negative or lost an electron by becoming more positive. So it's extremely useful. There are a few rules. There are some elements that like to have the same oxidation number all the time. So let's do the easy stuff first, the low shelves. If you've got an ion, okay, if you have an ion, that oxidation number will be the same charge as the ion that you're looking at, which is good. That's just easy. If you have a fluorine atom, fluorine atoms are generally -1. If you have a hydrogen atom, hydrogen atoms, especially hydrogen at the beginning of a formula, H something, will generally be +1. Oxygen atoms will generally be -2. Now, there are exceptions to this. If you were to have a peroxide like H2O2, it's no longer -2. But for the most part, oxygens are -2, hydrogens are +1. Then any charges would be -1. Also, if you have groups 1, anything in group 1 tends to be +1. Anything in column 2, group 2, tends to be +2. Anything in group 3 tends to be +3. Okay, so that's really all you need. That and one more piece of information. When you make a compound, that compound is equal to 0. If it's a neutral compound, then the charges will add up to give you 0. If you've got a polyatomic ion, the charges will add up to give you the charge of the ion. So let's look at these examples, and hopefully you can pick this up as you go. Aleks has highlighted the carbon, the chlorine, the oxygen, and the vanadium in these examples, and I ask you to fill in the oxidation state of the highlighted atom. So what's its oxidation number, or what charge will it normally like to be? Well, let's take this first one. I don't know what carbon is because I wasn't told what carbon is usually, but I was told that oxygen tends to be -2, and that the sum of these three -2s plus carbon is going to equal -2 because I've got a charge of -2. This is an ion. So I've got -2 times 3. Well, -2 times 3 is -6. All right. Now, what plus -6 will give you the charge? Okay. So you're going to say x plus -6. I'm just going to say -6. X minus 6 equals the charge. X minus 6 is -2. Well, what do? I'm going to add 6 to both sides. And so this would be +4. The charge of that carbon is +4. All right. Chlorine. I forgot to tell you a rule. This is an easy one. Anything in its free state, any element that's just one element, not a combination of more than one element, but just one element, is always going to have an oxidation number of 0. So here's an example where I have chlorine. It's a chlorine compound. It's chlorine with chlorine, but since it's just one element, this is chlorine in the free state, and this is going to be an oxidation number of 0. It doesn't have an oxidation number at all. Okay. Now what about the oxygen here? Rule of thumb is that it's going to be -2. Let's see if it works, because remember, if I add them all up, it's going to equal the charge of +1. So if I had -2 plus what gives me +1? Well, this is 3 positives. So I have 3 minus 2 okay, equals positive 1. Well, yeah, it does. So this must be negative 2. And you could almost memorize that. Oxygen is usually negative 2. Okay. All right, last one, vanadium. Well, vanadium is an oxygen compound, so I've got negative 2 times 5. All right, so this is negative 10. What adds up to be positive 10? Well, I've got 2 vanadiums, and together they're going to equal positive 10 so that they can cancel each other out, cancel the negatives out. That means that has to be positive 5. All right, so this is just little. Let me do this again. I'm sorry. I didn't see that you couldn't see. You see? All right, so I've got carbon was x minus 6, because negative 6 was the oxygen. 3 times negative 2 is negative 6. And then hydrogen, or the carbon, is something minus 6 is negative 2, so that's 4. And then here, 3 positive 1s minus 2 equals positive 1, which is true. Okay? Hope that helps.